Okay. So he's going to check mine for no reason.
How extreme we're going today.
You know what it takes to get a big guy down? Another big guy.
You're sure about that? I saw two.
Answer should have been 1.
Oh, here we go.
I know what I'm doing. I know it's not going to be right.
3.
God, let's go.
Today's objective is a brand new one. Extend polynomial identities to the complex numbers. For example, rewrite x squared plus 4 as x plus 2i, x minus 2i. This is not as rough as it looks. Well, if you remember the difference of 2 squares, then it'll be easy. If not, we can review it before we go through it. The difference of 2 squares. You remember when you have 2 items that are both perfect squares and they're subtracted, you can factor them out as a plus b, a minus b. Just alternate the signs. Does that ring a bell? We can look at a couple like that before we go into the rest of this. If I had x squared minus 36, all you do is find the square root of x squared, which is x, and the square root of 36, which is 6. Alternate the signs. And once you do that, you set each quantity equal to 0 like this, and then solve. And the answer essentially comes back to be the opposite of what was written in that quantity. So if you want to, you can skip this step, and once you see this, just write -6. You see that, write +6. So -6 or +6 would be the answer. Here's the difference of 2 squares. X squared minus 81 equals 0. What would I do first with this?
X plus 9, and then x minus
Right. That's it. -9 or +9? No. What we're doing is easy if you know this. If you know this, then it's going to be easy today. X squared minus 144 equals 0. What would I do? X plus 11 or 12? 12. X minus 12. And what would be the answer? -12 or +12. You could also write plus or minus 12. Saves you some ink or lead. You can do a sum of 2 squares problems if you understand the complex numbers. Remember what we just went through, the I squared, I to the third. So here's a refresher on imaginary numbers before we go through this. What would the square root of a -9 be? Not -3. There's a 3 in it. 3i, that's right. Since you have a negative sign under there, when you take the square root, whatever the square root of 9 is must have an I with it. What's the square root of a -16? 4i, right. What would this one be? Yep, 10i. Now, what would the square root of -1 times the square root of -1 be? I to the second is the same as I squared, which is the same as -1, right. -1. Or the shortcut is, when you multiply 2 radical terms like this that are identical, the answer is the number under the sign. So if I had the square root of 1, or just make it 19, square root of 19 times square root of 19 is 19. Okay, so you're ready for the first example. x squared plus 100. Whenever you have the sum of two squares, your first step is to rewrite this not as plus, but two different signs that are equivalent to plus. What sign combination do we always change to plus? Two negative is right. So you're going to write x squared minus a negative 100, which is the same as x squared plus 100. Now, once you do that, you can go through and do what we did before with the difference of two squares. You're going to have two sets of parentheses, set it equal to 0, square root of x squared is x, alternate the signs, but now you have the square root of a negative 100. Now, what is the square root of a negative 100? 10i, right. So we'll have x plus 10i, x minus 10i. And you know from before what you can do to get the answer is simply the opposite. It's going to be negative 10i or positive 10i. To save ink and lead, what you can write is plus or minus 10i. Example 2. X squared plus 121 equals 0. What do I do first?
X squared plus minus negative.
Right. That's right. X squared minus a negative 121 equals 0. So now what do I do?
X plus square root of negative 1.1.
Right.
And x minus the square root of 1.1.
Right. Negative 121. Now what?
It'd be 11i or negative 11. Yeah.
So you would do plus or minus 11i. Everybody had the right answer on this problem. It should be plus or minus 8i.
Remember the eye.
Almost everybody had it. It's plus or minus 14i. These don't count against you. They don't factor into the total points, but they do count as extra if you get them right. 5 points each. Block letter. Give me the block letter of the right answer. Give it your best shot. A is negative 1. So in this part here, if you insert a negative 1 in the exponent, it goes there. And then for the other part, you have the a that's on the exponent. That would just make it negative 1. This becomes x to the negative second when you multiply the exponents. And this one over here simply reverses. It flips and goes to the bottom. That's the rule of a negative exponent. And it's acting on the entire quantity, so both 2 and x go to the bottom. Notice this one has a negative exponent, so it must also go to the bottom. Now, since the numerators are equivalent, they're both 1, that means this equals this. So what number can I put in for x and square it that would give me the same thing as multiplying that number by 2? 2 is the right answer, so it should have been J. If you remember the midpoint formula, this becomes very simple. The midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. So if you add up the x1s, that's 15 and 3. 15 plus 3 over 2, and then the y's are negative 6 plus 5. That's going to be 18 over 2 and negative 1 over 2. That's 9 and a negative half, which is A. Okay, 2 to some power is 16. What is 2 squared? 4. What is 2 to the third? 8. What is 2 to the fourth? 16. So you know that this must be equivalent to 4. So when you do that, you end up with 6x equals 12. Answer should be 2. Example 3. Things that are not squares. For example, x squared plus 10 equals 0. You still do the same first step by writing it as minus a negative 10. And then you break it up. X plus x minus, you put in the square root of negative 10. But the only thing you can do to simplify that is take out the I. So you have I square root of 10 in both of them. And your final answer would be plus or minus I. Should fit the I in there. Square root of 10. Written very poorly. Plus or minus I square root of 10. There we go. Example 4 has one that can be simplified. X squared, and that should be plus 20. So you still break it up as a minus a negative 20. So you have x plus, x minus, and the square root of negative 20. Now you can take out an I just like before, but when you get down to where you have your final answer, you have to recognize that square root of 20 can be simplified. What perfect square goes into 20? 10's not a perfect square, but 4 will go into it. So plus or minus I square root of 4 square root of what? 5, yeah. 4 times 5 is 20. And then when you write your final answer, you need the square root of 4, which is 2, and put it to the left of the I, and then your square root of 5. So it's all the same, except when you get down to here. If you have a square root that can be simplified, if there's a perfect square that will divide into the number under the sign, you must simplify that before you come up with your final answer. For this problem, it should be x squared minus a negative 32 equals 0. Break that up as x plus the square root of negative 32, x minus the square root of negative 32, and you're going to have x plus I square root of 32, x minus I square root of 32. Now for our final answer, plus or minus I square root of 32, we have to simplify. What is the highest perfect square that comes out of 32? 16 is right. So it's plus or minus I square root of 16 square root of 2, which means our final answer is plus or minus 4I square root of 2. On the practice problem, x squared minus a negative 48 equals 0. Break it up, and it's going to be x plus the square root of negative 48, x minus the square root of negative 48. And then you're going to take out the I. And once you do that, you can go to the preliminary final answer, which is going to be plus or minus I square root of 48. However, why did I put that in there? Should have been an I. There we go. And we can break this up as plus or minus I square root of 16 square root of 3. So that would be plus or minus 4I square root of 3.